Greetings everyone, we are from Team HyperX and today I will walk you through our demonstration of custom TAP-PFN which we use to solve level 1 of Shell AI hackathon. So basically here I have the backend code for TAP-PFN. As you can see, I have made a custom TAP-PFN which could be imported for other codes. I also have downloaded the weights here, and this executor file I will be deploying on modal.ai. As you can see, I have already configured it and now I will be deploying it. So modal deploy executor.py. It would take a few seconds. By the time it finishes, let me give you a brief overview of what is in there, the executor file. So basically, we have created an image where we serve our Python files, and the GPU we have selected is currently H100. You could also select other GPUs like T4, A10G, etc. And here we have uploaded our model weights and also added the custom tab.pfn file. So in the custom tab.pfn file, you can see that normal people could directly use it by importing from custom tab.pfn, import custom tab.pfn regressor. Now they do not need to worry about the rest of the code. They could directly import it and use it like a normal regressor. So let's see, it's being created. It may take a few more seconds. So it has successfully installed all the requirements and now it's uploading the image onto our cloud. The image build has been done and now we have deployed the app on Modal. So here the app will be listed here. So currently there are no function calls. I will proceed with the actual front end code where we'll be using this. So here is our front end. We have created this using Flask, HTML, CSS, Bootstrap, and we have also added UI functionality of dark mode, light mode, and here you could see on the front page you could see a brief overview of what our team did. We actually achieved a 10 times faster processing because we used tabular networks and specifically tab.pfn, which was made for smaller datasets. Our team achieved an accuracy of 94 on the leaderboard, and we were able to process that 2000 rows dataset, the training which was initially given to us in round 1. So basically, we have divided this into two parts. Either you could directly do your ML analysis where you drop your train and test.csv file and let the model do its job. Or if you are interested, you could write your own custom code or tweak the code according to your use. And here is a brief overview of our presentation by Team HyperX for Shell AI Hackathon for sustainable and affordable energy. You could play it. Our team members Ashish Bachchan, Abhishek Sood, Sahil, Rohan. And so initially we did try with XGBoost, CatBoost, but we got the best result with TabPFN. And on top of that, we added some of our own feature engineering to further boost our scores. As you can see, our scores kept on rising with TabPFN. So like we also have a documentation for our a website. You can see that. In this, we have a brief overview of TabPFN. It's actually pre-trained on synthetic data, so it's quite amazing that synthetic data is able to produce such a good accuracy score on real world blend properties. Also, since this is trained on synthetic data, there is no chance of data leakage or anything like that. So a quick start guide would be to install tabpfn using pip install tabpfn, and you could directly import tabpfn like this. From tabpfn import tabpfn regressor. There's also a classifier, but for our problem statement we had to use a regressor only. For with tabpfn we were able to achieve 10 times faster processing. Since it's based on neural networks, it gave better score than those based on trees like random forest and XGBoost. And we did not do much hyperparameter tuning. We only added feature engineering on top of it to slightly increase our score. We made use of Python, PyTorch, and CUDA. You could also read our documentation, which we will be attaching in the final submission. Here is the documentation you could read, or you could download it, print it as you wish. Now, coming to the steps, here is a complete code which we have submitted for the final score on Shell AI. Now, this code might be looking humongous to you but we have broken down this into smaller steps. Even better would be like I could show you directly in the code runner itself. For example, we have two sections. You could write your own code, or you could directly drop your training data, testing data, and it will run on to our original submission code Python script, which takes training and testing.csv and gives out the output CSV as per the initial problem statement. This, as I told you earlier, runs on modal. Like this is our modal function, and currently we are using H100 on this. So we have like a credit limit of $5 as a free account. But this okay. Now in Code Runner, you can see it's a code playground where you could write your own code, you could upload your files, and you can run your code yourself. For example, let's say there are also some templates. Either you could choose to write your own code here, or you could directly import something from the templates. Let's say I import the custom tab pfn regressor, and this code actually, if you go to the original tab pfn documentation, this is their basic regression code, but instead of tab pfn we are going to use custom tab pfn. Okay, let me just show you with original tab pfn. So our code editor is also an actual editor. We created this using code mirror, so these themes are actual, the line numbering, etc. You could also copy your code, clear your code, upload files if needed. Currently this code does not require any more files, and you can run your code here. So this will be getting executed on the cloud, and our code constantly relies on polling requests. Like I could show you on the dashboard itself, the function call is being executed. As you can see here, the function call is being executed, and it may take some time. Okay, so in 13 seconds the function call was executed. As you can see, the mean square error is 10 and r square is 0.86. So by default the demo code gave us an error of 10, and let's try with our custom regressor. Custom tab pfn regressor. Okay, so you can take a look at this. Let's run. Here also you could monitor your code in the dashboard itself. It takes a bit time to get refreshed. Here you could see we also got a startup of 0 milliseconds. It's because the modal uses Rust containers, and it's actually kind of a container was warm. That's why we could achieve startup time of 0 milliseconds, and the GPU rates are also very affordable. That's why we could use it. So here we reduced our array to 8.85. However, since the dataset did not have other features and ensembles, it gave us a warning. You could also try out other codes, like you could write your own code here, or you could check our original actual submission code which we submitted. So it's the complete code, but for that you need to give it a test and train.csv files. And we also have weighted average. Like weighted average we did When we got 94 score, so we took our best and second best and we tried to average them out. Maybe we could, in the hope of improving the further output of MAPS score. You could try out these scores, write yourself. It's up to you. And just in case the codes do not work, we have also given an alternative access on GitHub. Here are custom tab and demo. You could maybe clone it, download it as per your needs. And our original submission code we had. So this was our original code, complete code. Similarly, you could check out for other codes we did average or even the blank script. So this was it. Now I would be showing you the demo with our actual original code and the test and train.csv files. So here was our code we used to achieve 94 on our leaderboard. And now I would be uploading the CSV files. So I would be uploading the test.csv and train.csv. So these are uploaded now. And now I will be running the code. It is going to get executed as you can see here in the dashboard. So there is that. A basic overview of our code is like we first imported all the stuff like sklearn, the transformers, etc. And we used GPU settings and we try to check if CUDA is available and we kept the data type to float32 for faster processing. And then we created features using GPU acceleration. Now you can see if GPU is available, use it, otherwise use CPU. Now it creates interaction features from component fraction, component property. The more detail about this would be in our documentation. More entropies, vectorized features, weighted statistics. These all feature engineering stuff. Then we apply it to our training data and testing data, reduce the dimensions, do clustering. And here are the tab PF and actual pipeline. Herein you could see if I scroll down, here this is where we actually use our tab PF and regressor model. Now we set ignore pre-training limits to true since tab PFN works on smaller data sets and this was a data set of 2000 rows in the train file. So we had to set it true to ignore those limits and our model path which we had already uploaded is here. So it does not have to download model every time it runs. It would directly reference to that path. And at last we clean the data and when we return the results after adding the ID column and return the results. So it's currently being processed. Since the data is quite big, it may take some more time. So it's been done in 2 minutes 38 seconds. Now we could review the results. So here are the logs, like it first trained for blend property 1, 2, 3, and so on. And here is our output file, which you can download also and save it. So that's it from Team HyperX. We hope you liked our presentation. Thank you very much.